Okay, so it's a a problem where it's involving money. It says the sum of money at a simple interest rate amounted to $1,868.40 in 7 years and to $2,174.40 in 12 years. Find the principal and the rate. So I'm going to write this down. P is principal. Whoops. The P is the principal and R is the rate. All right? So I got to write this down. And write this down. It's simple interest, right? So let's write this down. So 1868.4 is, well, it comes from the principal, and plus there's 7 years of interest. So what's that going to be? 7, and the interest would be PR, principal times the rate. All right? Now, it goes on to say that in 12 years, it would have been a different amount. And that makes sense to me. 2174.4 equals, well, it's principal, but now it's been there for 12 years. And the interest, simple interest, is P times R. All right? And I got a problem here. I got two unknowns. And, I'm looking at it, and I think I could probably solve this. And the way I'm going to do it, I'm going to just subtract the two. Oh, you know what? Maybe not. Maybe I'll look at 7 and 12 first, and I want to suggest something else to do. So I'm going to multiply the top equation by 12, and I'm going to multiply the bottom equation by minus 7. All right, now as I do that, I'm actually going to use a calculator to do it, and I'm going to get my calculator out. And the reason I'm not going to say they're bad numbers. You could do it by hand, but I got to get my Sage calculator out, and I'll write this down. And what do I get? I get 12 times 1868.4 minus 7 times 2174.4, and I get 7,200 now. I'll write that down for you. 7,200. And then what do you get? You're going to get 12, because 12 times P is 12P, and minus 7P. And that's going to be what? 12 minus 7 would be 5P. All right, now the other ones I'm not going to do because 7 times 12 and minus 7 times 12, they would disappear. So now I know what P is. And what's P? Well, P would be, let's see, 1440. But again, if you want to take a calculator, it's 7,200 divided by 5, and that's 1440. So I got the principal. Now the question is, how do you get the rate? And, again, I'm going to use a calculator. I hate to say it, I'm going to use a calculator. And you need to pick an equation, and I'm going to pick this one over here. And you're going to get, I'll write it down for you, 1868.4, and I'm going to factor the P out. And so the P is 1440, right? And then what do you get? You would get 1 plus 7R. All right? So, if I were to do the computation, I'll tell you what the computation would be. 1868.4 over 1440, and that would equal 1 plus 7R. I'm going to use my calculator, don't worry about that. And what do you get over here? 1868.4 over 1440. These are kind of nasty numbers, I know that, so I'm using the calculator. Minus 1 equals 7R. And then I would divide both sides by 7. So 1/7 times 1868.4 over 1440 minus 1 would equal R. And I'm going to do that right now in a calculator. So I'm going to write down 18, and the calculator I'm using is Sage, by the way. 1868 0.4 divided by 1440 minus 1. And then I'm going to take that and multiply by 1/7, right? So I'm going to take that and multiply it by 1/7. And I get 17. It's a crazy looking number, I realize that. I get R is 17 over 400. Now, by the way, I'd hate to say that to somebody. I really would. And it's an interest rate, isn't it? So I got to take that rate, which is 17 over 400, and I need to tell someone what the percent is. How do you do that? You multiply it by 100%. And what would that give you? Wow, that gives you 17 over 4%. But again, I would hate to say it to somebody. I really would. If someone said, oh, what's the percent? I say, oh, it's 17 quarters? They'd wonder what I was talking about. So I need to write this down in a little bit more reasonable way. So as 4 goes into 17 4 times with the remainder of 1. So 1.25%. That's one way you could say it. I think nowadays, though, people might be confused when you say that. I'm going to say 4.25%. All right, let's look at the K. And again, I use my calculator. You can say I'm cheating, use calculator. Yeah, and according to Wells, I'd be cheating. He'd find it to be a miracle someone could do that. And I get this over here. Not a bad problem, by the way. It really wasn't bad. What was bad? The arithmetic in that problem was bad. Thank you.